Welcome to day 2. It should be day 3, but they didn't let us have class on Monday. So we met Wednesday, then we have 5 days apart. And now it's day 2, and we'll be wrapping up the endocrine system today. So even though we're starting a little late, we have a ton to do today. First thing I'm going to do is anybody that wasn't here last time, I brought you a place where a tag that you could put your name. So you got that. I haven't checked Blackboard to know if you guys did the introductory assignments yet, but they were due last week. Even those of you that were here, make sure you go into this part of Blackboard. Your AMP1 class may not have had it, so I want to make sure that you guys know about it. Module 0 are all 5 of those early assignments. Contract, first day assignment, biography, learn anything, and your navigation. And this may be different than your AMP1. For our class, the navigation needs to be emailed to me, okay? And so I'll be looking at those assignments later today and early this week and getting everything graded on that. None of those are about AMP content, just so you know. It's just about background information about you and for the course. Okay, so moving into what we need to do today, let's go to our blank PowerPoint. That's what this was, the blank. And the last thing we did was this image right here. So I'm going to start with this and see who looked at their pictures 3 times a day for 5 days by asking questions. All right. There's the photo. Okay. Anybody remember what gland was this? Good. That's the pituitary gland. I'm going to write that up here. Little reminder. The question on the test might not say name the gland. It might say name the organ, because the glands are the organs in the endocrine system. Every gland is its own organ. We want to make sure early on it's important to know that so that there's not confusion. This, if we look right in here, let me use that color. Right about there is the dividing line between 2 different tissue types. And it just so happens on this gland that each of those different tissues is actually functioning like a different gland. We choose to call those different portions the 2 regions. So who can tell me, what did I write here to help you know which region this is? Dark. And how did I write dark? There you go. Wrote it like that, right? So the A stands out so that we can remember, oh, that's the anterior pituitary. So this region is the anterior pituitary. What does that make this region? Posterior. And here was our memory device. This posterior pituitary. There's 2 reasons the posterior is special. 2 things about it that are different than almost every other gland. Can anybody tell me one of those 2? Very good. It does not produce any hormones. So no hormones produced there. Big H is hormones in this chapter. Anytime I use a big H, it means hormones. No hormones produced here. Where are the 2 hormones that we talk about from here? Where are they produced? Very good. They're produced up in the hypothalamus. Okay. And the other rule breaker. What tissue type is this? Very good. It is nervous tissue. Very few glands are nervous tissue, okay? This is the main one that we have you identify as nervous tissue. Obviously, the brain ones, the hypothalamus and the pineal are nervous tissue, but we don't see their slides. This is the only one that we have a slide of that you will be identifying under a microscope that is nervous tissue, okay? The two hormones, there are two hormones, however, that are very good, I heard, released. What are the two hormones that are released from here? Nice. Oxytocin and ADH. There you go. Oxytocin and ADH. And how many hormones were made by these cells? 6. And what is the tissue type of these cells? Okay. Cuboidal. Epithelium. Okay. Cuboidal epithelium. So for those of you that weren't here last week, this is one way that this class is completely different than AMP1. We do a lot of marking up stuff on the board, and then I have you get out your phone and take a picture. So this is our first picture for today. This way you have it exactly like we did it in our notes. So here's picture number 1. Since people started taking pictures of what we do on the board, the grades have gone way up on the lab exams. I'll just be honest with you. I've noticed that people that don't take pictures don't do as well on the tests. Because when you see it exactly like it's going to be, it helps you remember. It helps you learn. All right. So, why did I repeat this? Because I wanted to get your mind back into thinking about glands, and back into thinking about tissues, and back into thinking about hormones. We have 5 more slides that we need to cover today that are going to be similar but different for 5 glands. And then after that, we'll focus on talking about some other aspects of this handout that weren't related to the pituitary that we didn't get to last time. Okay? If, just so you know, if we don't quite get finished with everything endocrine today, that's okay, because our next lab, the blood lab, is one of the shortest labs we do. Okay? It's not a whole class period. So I actually have time built in. We could take an hour to even up to an hour and a half of our next class to finish up endocrine if we need to. So just so you know, even if we don't get done, we're not truly behind. But the more we get done, the earlier you have that information, the more you can start preparing on your own. Okay? So here's the next gland that we'll do together. Now I'm just going to remind you by going back to here. Let me do this. I'm going to go ahead and change my order. It'll make it easy for us today. I won't change it permanently, so I won't save it. But look at that. How many tissues do you see? Major tissues, remind me. 2. And there's a really nice line that separates them right about there. It's not a perfect line, but boy, you can see where those tissues come right together right there. Look at this. That just kind of looks messy and all over the place. If you look through here, you see lots of little tight clusters of things. And notice, you see like it almost looks like a little road going through there. A little road going through there. And these, if in your head, you could think of them like if you're looking at Zillow for houses or something, it looks like, look, there's a person's property. You can see how it's separate from the next person's house and the next one. So it's weird like that. But watch here. Everybody can see this. This thing, this big round thing right here is obviously different than all the rest of it. There's nothing else like that. Okay? That thing that we're seeing right in the middle, that's the gland that makes the hormones. Okay, that thing in the middle. So first off, right off the bat, this doesn't look anything like the other slide because there's not two tissues that just completely come up to each other. What we see is one kind of stuff with another thing embedded in the middle. Okay, and it's pretty circular. It's pretty round, so to speak. So let me tell you what we're seeing first off. This is our pancreas. This is our pancreas under the microscope. This part of the pancreas right here is the part that makes the hormones. So we call it, we're going to name it something, but for right now I can tell you it's the endocrine region. Okay? Its name for this structure you know how AMP is, everything has a name. The name of this structure is this. It is an islet of, I don't know why this guy had such a long name, but he did. Langerhans. That thing there is called an islet of Langerhans. For the endocrine system, that is our important part of the pancreas, that islet of Langerhans. Because that's the part that produces the hormones. Okay? Now, you don't need me to know what hormones are there. Can anybody tell me why you don't need me to know that? I see people already reaching because they're all on here, right? So go to page 2. Oh, you guys don't have the sheet yet. Anybody from last time not bring theirs today and you need it? I have extra copies. Good. So if you go down about, and I'll turn the light on to change things. What hormone am I chasing away when I turn the light on? Melatonin. Melatonin. Trying to chase it away. All right, page 2 on the back. Pancreas. What are our 2 hormones from the pancreas? Okay, let me ask you this. Which one have you heard of before? Insulin. Insulin. There you go. We have heard of insulin. Just want to see, just curious. Anybody ever heard of glucagon outside of a classroom? Yeah? Do you work in a pharmacy or in a hospital? You have? Okay, that's because most people have heard of insulin, and commonly only healthcare workers know about glucagon. Okay? So, here's how we're going to kind of get started on this. Hey, did I leave my pen somewhere? There it is. Let's use, I think we'll be able to see the blue. So here's what I'm going to write in here. Insulin and glucagon, because those are the hormones that are produced there. They are produced there. Remember, the posterior pituitary that we just finished, it was the rule breaker. It doesn't make anything. Every other gland we do, wherever the hormones come from, where they're released from, that is also where they're made. That is where they come from. Who remembers what kind of blood vessel we must have in here for these hormones to get into the blood so they can travel through the blood? Perfect. So I'm going to draw our cute little capillary. There's a little capillary there. Now, it's not one capillary in there. There's going to be thousands and thousands of capillaries in there because they're small, or at least hundreds, or at least dozens. There's a lot of them, okay, because they're little. So that gets in the blood and it travels. But look, we still have all this other stuff. So what's all this other stuff? Well, it's kind of interesting. I don't know if I completely said it to your class. I think I did, but I'm just going to double check. I know I said this part. Most glands are which tissue type? Cuboidal epithelium, right? Most glands are cuboidal epithelium. The only one that we really study and see a picture of that's not cuboidal epithelium is which one? Posterior pituitary. So let me ask you, what do you think that means the tissue type is in here? Cuboidal epithelium. It is. So real quick, just so you can see it, so I can show you this, I'm going to erase everything, but I'll put it back. Remember, I'll always let you know before I totally clear it. The way that we tell something's cuboidal, I don't know if you remember this from last week, or once again if I said it, we actually look at the nucleus. And if the nuclei are all round, then the cells are usually square. They're little cubes. So when we look in here, and I know it's not zoomed up great, let me zoom it up for you guys. And if I zoom that up a lot like that, look at all those nice, gorgeous little round nuclei. That is cuboidal epithelium. And by the way, if you come out to this other tissue here, those nuclei are also round. I know it's hard to see. So here's what I'm letting you know. Whether we're talking out here, all of this stuff, or in here, it's all cuboidal epithelium. Most of the pancreas is cuboidal epithelium. So I should have never zoomed it. Oh, yeah, just turn your ringers off. Put it on vibrate, or maybe not even vibrate, just look for it. Let's do this. Hey, good enough, that'll work. So back to this. Within the pancreas, because there's all this other stuff out here, these little parts out here, I just want you to know, get a head start for what we're going to do later. Remember, pancreas is mostly digestive. It does make hormones, but it's an organ of the digestive system too, just like so many other endocrine organs do something else. This portion, or these cells, have a completely different function. They do not make hormones. What these cells do is they make digestive enzymes. They make digestive enzymes. And so they call this region, the pancreatic, acini. Okay? They're acinar cells, or the acinar region, or just the acini. The odds are on the lab test you're not going to see acini on this lab test. I'm giving you that information to build your knowledge for the future, because that could show up when we get to digestive. And I know that anything I teach you now makes the end of the semester easier. You might remember how we talked about that in AMP2. We heavily load information into the front. So we do a lot of reproductive stuff now. We do some digestive stuff and some other organ stuff now. And it just makes it easier for us later. Okay? All right. So how do I want you to know this? Aha. I might point to this and say a lot of different questions. One question would be, name a hormone produced here, and what's your best answer? Why is insulin the best answer? Because it's easier to spell. Okay? Glucagon, look at that word. One, it's hard to say, glucagon. Okay? People put all kinds of other things in there. So when it's harder to say, it's harder to spell. All right? And when you're taking a lab test, we want to focus on that. The other thing is this. We've heard of insulin, and almost nobody's heard of glucagon. So that's what makes glucagon harder. All right? After a while, in a little bit, I'll come back and talk about what, on the next picture, we'll do this right away. We'll talk about what insulin and glucagon do. The neat thing for you, they're opposites. So if you know what one does, you can figure out what the other does. And we'll talk about that in just a second. So let me come here, and down here, I'm going to write this. What question would I ask if I wanted cuboidal epithelium as the answer? Excellent. What tissue is that? Okay, what tissue is that? Pancreas, islet of Langerhans, insulin and glucagon. The acini make digestive enzymes. One other very important thing. Well, there's actually two. When you were in AMP1 and you studied glands for the first time in that tissue chapter, all of the glands you studied then were called exocrine glands. Studied sweat and saliva and stuff like that. I don't know if you remember, so here's where I remind you. Every exocrine gland secretes different than endocrine. Endocrine glands secrete their hormone into these. What are these? Capillaries. And little capillaries are representative of the blood. So we say endocrine secretes into the blood. Exocrine glands always secrete. Very good. Exactly. Into a duct. And there's our duct. So I love this picture of the pancreas because they include the duct. So you can see that. It's ready for your picture, for one. And then we'll keep talking about it. Okay. And here's, so just a little kind of how cool this is. These are little cuboidal cells, and they're formed in little clusters. So there's a whole little cluster of cuboidal cells right there. There's another little cluster right there. So these are little tiny little groups of cuboidal cells. That's why it's hard to see. But these cells make digestive enzymes. And you see the little white spaces here? It puts the enzyme in the space, and it works its way to this. And then now the enzyme is in here. And all of these, this duct would come down and go right under there, and they would attach to that duct. So all of these little trails that you see up there, all of those little trails are spaces where the enzymes can work their way toward the duct, and they can find their way toward the duct. There's nothing for you to know about that. That's no kind of test answer or anything. That's just when you look at this and step back, you see all those little pathways where the enzymes can find their way to get to the duct so they can go wherever they're going. Okay? And we'll talk more about that when we get to digestive. Okay? What all of that leads us to is this, though, and this is a great test question. Are you ready? There's only one gland that we study that's both endocrine and exocrine. Which gland is it? Pancreas. It's the pancreas. So I would write that, okay? I mean, I know you see it here, but I would have that somewhere because it's so good. Even on your hormone handout. The pancreas is the only gland that you're going to be asked about that we study that is both endocrine and exocrine. That's a test question that shows up on lab, and it loves to show up in lecture too because it's that important for helping us to understand this gland. All right, once again, if you didn't get this picture, now's your chance to get it because it's about to go away. All right, if you got it, great. That's it. Anybody want to remind me? I never know how this thing's going to act. Sometimes it's nice, sometimes it's not. What gland is that? It is. It's the pancreas. What disease have you heard of that causes people to have high blood sugar? Good. All right, diabetes. We've all heard of diabetes. Diabetes very commonly causes patients to have high blood sugar. Okay. Now, we don't have to call it sugar. We could say glucose if we want to be fancy. So keep that in mind. Sometimes a patient, whether it's animal or human, that has diabetes might need to inject a medication. What medication might that be? Insulin. So look at that. Synthetic insulin is a medicine. It's also a hormone. So when you inject it in, it gets into their blood and it goes everywhere and it acts just like the body's insulin. It's pretty cool. Why would that person be injecting insulin? What's the job of insulin? That's it. You guys got it. So watch this. Here's what we're going to do. We're going to come over here. I'm going to remind you that this, I'm just going to write pan, okay? It's for pancreas. That's our pancreas. One of the hormones from the pancreas is insulin. And the job of insulin is to, very good. You can say decrease, lower, reduce. There's lots of words that mean make it go down, right? The job of insulin is to lower the amount of sugar that's in the blood. Bless you. To lower the blood sugar. And so this is one of the things that I love so much about what we do, like in A&P, is there's all kinds of little helpful hints I can give you that are going to help you stick when you go into whatever healthcare program you want to get into. And the first one is this. Insulin and glucagon are completely the opposite. We mentioned that a while ago. The fancy way to say that is this word. They're antagonists. Antagonists mean that they're opposites. Okay? And so, what did insulin do to blood sugar? It decreased it. So if insulin decreased it, then glucagon has to do what? It must do the other. It must raise it up. So here's the first time you'll hear this, but we'll do it a little bit later today. Whenever you have opposites, you don't need to try to memorize them both. Make sure that you pick one that you are going to know really well, that it's going to become your favorite. I highly recommend this one become your favorite because we have some knowledge of it. And that just makes sense. We have a hook. Most of us knew insulin lowered blood sugar, and if you didn't know it before, you probably already picked that up. So the way to learn glucagon and the way to lock it in your memory is not by keep on saying it raises blood sugar. Don't worry about that. Say it's the opposite of insulin. And if you get a question on the test about glucagon, here's what I recommend you do. Oh, he's asking about glucagon. Insulin lowers blood sugar, so glucagon has to raise it up. Okay? That's how you learn something without confusing it. And I'll just tell you, I've taught this for a lot of years, and this might sound familiar to you. Have you ever been taking a test, multiple choice test, probably in high school, but maybe in a college class at some point, and you narrowed down the 4 answer choices to 2, and those 2 answer choices were like opposite of each other? Let's just pretend it's this. And the question's about insulin, and the answer is raises blood sugar or lowers blood sugar. And your brain goes, I know it does blood sugar, but I forgot which way, right? And then, so you pick an answer and you go with it and you move on and you're taking the test later And there's the question again. You ever had the same question show up twice and you narrow it down and you don't know the answer? What do? Do you pick the opposite so you at least get it right once? Yeah, right? Or some people go, I'm going for it twice, and maybe you miss it twice. Hey, so you never have to do it like that again with some of these. Just pick one and own it. Own insulin. What does insulin do to blood sugar? What does insulin do to blood sugar? What does insulin do to blood sugar? So glucagon has to do the other. It has to raise it. And if I promise you, if you learn it like this, you'll remember it when you get in your program, and you won't have to re-memorize it again. If you just try to memorize it for the test, this one does this, this one does this, this one does this, this one does this. On test day, they get confused. And what's worse than that is later on, they really get forgotten. So pick one and own it. We have 3 great examples of opposites. There's really some more, but we're going to do 2 more good examples of opposites too. So let's put it up here. What's the opposite hormone to insulin? Glucagon. And I'm just going to put it here so you have it in your picture. What does it do to blood sugar? There you go. And I'm going to write it a different way, okay? So it's not so easy to overlook. So there's your picture. That's it for this one. Very common on the lab test. You know, there'll be a lot of pictures on the lab test, but you'll also just have a question. You'll be taking the test and there'll be no picture, and a question will pop up and it might say, what is the function of insulin? What should you write? Lowers blood sugar. Perfect. And you get full credit. And move on. All right? So that reminds me to mention this to you. In lab, when you're asked about a function on a test, if you want full credit, never say regulates. See, if you say insulin regulates blood sugar, it does. I'm telling you, it does regulate it. That means you don't know if it regulates it down or if it regulates it up. You're just kind of like, it messes with blood sugar. Which way? I don't want to commit. If you put regulates when I ask for a function, because we teach very specific functions, I will give you partial credit, but you can't get full credit. And I know you're trying to get as much full credit as you can in every one of these questions. Okay. All right. That's it for the pancreas. That's really how simple the pancreas is. Okay. Oh, truth be told, pancreas makes more hormones than what we teach. Pretty much every gland we study makes more hormones than what we teach. Remember what we're doing in class. We're laying the foundation. Okay. We're not teaching you everything. We're not trying to make you get your PhD in the endocrine system. We're just trying to give you a baseline understanding of how hormones work in the body. Hey, look, we're only going to do 6 slides. We've done 2. What gland? Wait, don't answer yet. I know some of you know. There we go. What gland is that? Pituitary gland. What letters does it start with? P. This one also starts with the P. Which one is this? Pancreas. Notice they don't look alike. Here's our next gland. Are you ready? I'm going out of order from my slides here. I'm going to pick this one. That's our next one. This is probably my favorite. This is a great picture. You know why I'm saying that? Because I took it. That's why it's great. Okay. So I took it in this room with one of these. But which version? This iPhone. Which iPhone did I take that with? 2? Did you say 2? Did they even make a 2? iPhone 5. That picture is over a decade old. Here's the crazy thing. If you come into the lab and you want to take pictures, like some people in AMP1 with Dr. Day did that. They went in and tried to take pictures. These things have 3 cameras now. The camera can't figure out which one to use, even if you try to make it mandatory. And it doesn't take a picture that good. This great phone that has 10 times the resolution of that takes a worse picture.
Android.
Have you tried that?
Yeah, I can take
You can take good ones?
Pictures and
Oh,
video.
then go buy your Android.
It has 3 cameras, but I don't know, they're in a line. You pick
They're in
the
a
top
line?
one and it works.
That one you can't, it shines, it creates
Yeah.
halos, it does all kinds of crazy stuff. So anyway, back to this. 1, 2, 3, 4. 5 of us in this room do not have this organ. Tell me what it is. That's the ovary. Very good. So here's our first run through an ovary. So I'm doing the ovary backward to how I do some things. This is zoomed up super close on the ovary. We're going to start with this, and then as we learn, I'm going to put more information out there and more information out there. So this is about as close up and specific as I could get on the ovary. So in AP, we pick and choose which names we're going to, okay? So that thing right there, that's commonly called the egg. We're not going to call it the egg, okay? But that's an egg. So you were that one time. Here's what we're going to call it in here. Because it's a cell, site means cell, and oo is used for a lot of female stuff, okay? So it is called the oocyte, the oocyte. If you are asked to name that, it could either be worded either way. Name that cell or name that structure, and I'm pointing right to the center there. You know, it looks like a little globe, doesn't it? It looks like a little world, a little planet or something. And that's because at one point, it was your whole world. It was you. You were just that. And then it got fertilized and you became more you. And then you got more cells and you became more you. And eventually, cells changed enough that it is you. So that's the oocyte. The oocyte is in a larger structure, this whole thing here, this larger structure right there, is called a follicle. Now, I'm going to add one more word to that because there's a lot of types of follicles in the ovaries. We're zoomed up on just this follicle. Who can tell me what the shape of that nucleus is? It's a nice round nucleus. What did we say about cells that have a nice round nucleus? They're usually cuboidal, right? Can you guys see? Right there. And by the way, I will let you see this also. We're marking it up. I'll let you see this one with the markup gone so you can see those lines that I just covered up because it's very clear. That right here, I'm going to just make it up there. That's cuboidal epithelium. But how many layers is it? It's one layer. It's one layer. So what do we call a tissue that is only one layer? Very good. So this is, look what this is. Simple cuboidal epithelium. Very good. So that is an example of simple cuboidal epithelium. If I ask you to name that tissue, simple cuboidal epithelium. Hey, if you just put cuboidal epithelium, you'll get most of the credit. If it's a 4-point question, you will probably get 3 points of the 4 points. But for perfect credit, since it's only one layer, we're calling it simple cuboidal. Only a couple of slides you'll see have simple cuboidal. The other ones just have plain old cuboidal epithelium, just a jumbled up mass of cells. Okay? That, because it's got one layer of cuboidal cells around it, that makes this follicle a very special follicle. So they give it a special name. So anytime the oocyte has a follicle that has this tissue around it, they give the follicle this name. Because it's really important. It's a primary follicle. That is called a primary follicle. If I want you to give me the answer, primary follicle, I will point to the outside of that and I will say, name that structure. If I point to the exact same place and say, name that tissue, right? Same place, same pointer. The question changes. If it's named the tissue, what's the answer? Simple cuboidal epithelium. If I say name the structure, it's a primary follicle. A primary follicle. And then if the pointer goes way inside of that to this, then it's the oocyte. Okay? What if your question says gland or organ? Ovary. Watch this. We'll take more knowledge that you have hiding in you. What if it says name a hormone produced here? Go to your handout, or maybe you know. What are the two common female hormones made in the ovary? Estrogen and progesterone. By the way, there's other forms of the hormones and other things. We don't really get into that. Okay? We just go with that. Because this is our introduction to this. Now notice, I did not tell you where the hormones are produced. Progesterone, we're not even seeing where it's produced in this picture. The estrogen is produced from these cuboidal cells, but you won't be asked that until we get to reproductive. When we get to reproductive later, I add that information. So for now, we're understanding that the epithelial cells are the ones that make the hormones, but there's not an exact question about that on this. It's a little early for that. We'll learn the follicles and the ovary better when we get to the end of the term. So there's your markup for this ovary picture. We are actually going to do 2 more ovary pictures, okay? 2 more ovary pictures. The next picture that I do of the ovary with you will not just have primary follicles, but it will have follicles that have a smaller epithelium, not bigger, smaller. How do we describe the shape of these little square cells? As cuboidal cells, right? Yes, 1 layer, you got it, simple, but they're cuboidal, that's their shape. So what we're going to do, when I show you the next slide, we're going to see a follicle that the cells are basically only as thick as that inside line right there. They're going to be that small. What would a flat cell be called? Squamous. You can say squamous, yeah. That's the British pronunciation. The squamous cells, right? So we're going to see the next picture, we're going to have a couple of them that look like this with cuboidal. And then down below it, we're going to see a whole bunch where what you see is an oocyte with just a line around it, basically. Because it's so flat, it just almost looks just like a line. So that's going to be a different kind of follicle because it's only got squamous cells. So let me show you what that looks like. I'll just make sure I have that picture real good. And so here it is. Maybe not as great of a picture. That's the picture.
It's gross.
But they probably took it 40 years ago and kept using it, right? That's just how it goes. So here, it's crazy, right? Just the iPhone 5. I mean, it just blows you away. What's this thing right here? Can do it. Oocyte, good. You know how you remember oocyte? It's a cell. Cytes are cells, right? When it got fertilized, what did your mom say? Uh-oh. So it's an oocyte. Because she said, uh-oh, here he comes, or here she comes. He's a baby. All right. What kind of epithelium is that? Cuboidal, simple cuboidal. Very good. So here's our primary. I'll mark it up for you in a minute. But look down here. This is the best example on the page. It's not great, but I will zoom up for you before I start marking. To about right there. Oops, there we go. There's the oocyte, and look at that line. That's a squamous cell. That's how thin it is. There's its nucleus. And then the cell gets thin again. There's another nucleus. It gets thin. There's the line around that oocyte. It's so thin. Look at this oocyte. There's its line around it. So thin. And this one, so thin. Still ugly. I know those are ugly. But remember how we do this. We started with the one that was beautiful so we could understand the knowledge. And then we transfer that to something that's not as great, but it gives us a concept. So these at the bottom, these follicles are smaller. See those up there? They're bigger. And these are smaller. Now, here's what you're seeing here. Doesn't that look thicker than the other squamous cells? Because what happens is these at the bottom, they grow and become those. So what happens is these little cells around the edge, they start to expand and they become cuboidal. So these follicles at the bottom turn into those follicles at the top. And then those follicles at the top keep growing. And guess what? Then they get more layers of cuboidal cells and they change their name. What would be a great name for a follicle after the primary follicle? Secondary follicle. Yeah. What would be a great name for a follicle before primary? I don't expect anybody to know that. There you go. Primordial. Primordial from biology means ancient, like that primordial soup. Yeah, there you go. But I ain't going there right now. So let me mark this up for you. And here's how I do it. Name this gland. I heard you. It was quiet, but I heard you. Ovary. Okay. Name this structure or cell. Oocyte. So watch this. Name that. Now I'll do this one. Structure or cell. Very good. It's still an oocyte. Okay. What tissue do we see there? So notice I'm going to abbreviate. We have it on our previous slide. I'm abbreviating now. When I abbreviate, it should help you when you review your pictures because your mind has to think about it. And when you have to fill in the blanks, that's when you're learning. And you're pretty soon you'll get to that and you'll see that and you'll know it automatically. Okay? What did we call this entire structure? Very good. We called it a primary follicle. We called it a primary follicle. So be very careful to point right there. And I'll go. Okay, what tissue are we seeing right at the tip of that pointer? Simple squamous. Because it's thin and it's flat. Right here, thin and flat. I'll write simple for that one. Simple squamous epithelium. And by the way, that's the same on most of these here. So I could point to any of them, but I'll just point back to this and go, here's the question now. Instead of name the tissue, I'm pointing at the same thing, but I'm saying name this structure. What means, what is that whole thing called? It is a follicle, and here's the word we said earlier. Primordial. It is a primordial follicle. All right. And so that is your ovary. that we're going to do. The ovary that we do is immature. It only has these two follicles. The follicles have not advanced to be the big ones. So it makes it much easier the first time you see one to identify those follicles when there's only two kinds. If they're tiny, they're primordial. If they're bigger, they're primary, okay? And they have that tissue type around them. So go ahead and get your picture, this version of the ovary. While you're doing that, let me mention something to you. When you were an oocyte, how long ago was that you were an oocyte? Wow. Wow. This is going to blow your mind.
Oh.
Yeah. So, yeah. I knew you knew it, but. So, I said the question to make you think just one way. And you were thinking, oh, I was an oocyte right before I was fertilized. Okay, good. But let me change the question. When was your oocyte created? Here's the answer to that. Your mom was born with all of her oocytes she would ever have. So your first cell, your oocyte that became you, is the same age as your mom. And your mom's oocyte is as old as your grandma. And your grandma's oocyte is as old as your great-grandma. That's how these oocytes are older than we are. It's really cool. It's really cool. And that's why, you know, they say with females, as you get older, you want to think about fertility sometimes. It's because at a certain age, you've had those oocytes your whole life. So when you're 30, your oocytes are 30, right? When a girl is 14 or 15, her oocytes are 14 or 15. When she's 50, those oocytes are 50, and things change with time. That's all. Okay, moving away from this one. Oh, but I need the picture of this one. It was too cool to not take the picture. The next one, this picture won't show up on all of your tests, but it might show up on some. So I still want you to take the picture. Let me see. It's not going to be in this PowerPoint. So I don't know if you remember from what I said earlier, because I said it so fast just when I was booting up. We have another PowerPoint in our lab documents area. And this one has labeled each gland so you can practice with them. And it just has a few examples of each, but I'm going to show you everything I need. I don't need you to open this and totally try to memorize all those other ones. Any one I want you to know, I will show you. Okay. The one I want you to see right now will look very familiar. It's the same one we just did. Let me show you where that came from. That came from this. So this right here, oh, that's all I'm going to get. I'll zoom it up just a little for you. That's an ovary right there. I don't know how well you can see, so I'm going to zoom in some more. Now I do. What is that? Oocyte. Which follicle is this? That's a primary. And what follicles are these? Primordial. Do you guys see that? So watch what I want to do with this. I'm going to zoom it back out. Look where those are when I zoom out. Look how they go to the bottom down there. Everybody see that? So here's what I want you to see. If you get this on the test, I'm not going to ask you the details. They're too small. But I want everybody to be able to see this picture of almost an entire ovary and just to know it's an ovary. The way that you know it's an ovary is you can see the little follicles with their oocytes all the way around basically the outside. Notice there's almost no follicles through the center. And that's how the ovary looks. The follicles grow around the peripheral aspect, around the outside. As they mature, they get pushed to the middle, and then they work their way back out. It's just how it works. So that's an ovary. What kind of question might I ask about this that I ask about every gland slide that's not too detailed? what hormones are produced here. What hormones are produced here. So if you got this picture, really the only kinds of questions you would get, name this gland or organ, and name a hormone produced here. I would not ask about the details. They're just too small to see. Okay. Also, I like to say this, if you know the painting Starry Nights, this kind of looks like it. It's really cool how things in the body resemble some other things. So that's the ovary. What would be the best slide to do after the ovary? Sure, why not? Let's do the testes. So here, let's start with our testes photograph that's the little one. We'll do the testes in reverse. Okay, we'll start with the little baby picture, and then we'll zoom up on the testes. Remember, that is the singular spelling for testes. I don't care if you use singular or plural. So if you saw this, name the gland. Remember we made fun of the fact that it's spelled testes, but it's pronounced testes. There it is. That's the testes. What you may not know, all of these things here, even the ones that are shaped funny, they are tubes, and they're so tiny that they changed their name and call them tubules, which means tiny tube. These tubes are the tubes that make sperm, and we'll say that many times. They give them a very crazy big long name. Seminiferous tubules. So anywhere on that, if I point to it and say, name that tube or name that structure, that is a seminiferous tubule, okay? All of those, even the funny ones like this. On this power, that's about all you can see. You can't see much, but you can see those. So I may ask those, okay? But what do you want to know which hormone would be produced here? Yeah, testosterone. So there is our first picture of the testes. Go ahead and snag that right there. Something to keep in mind when we're doing these tissues, this isn't a histology class. I'm not trying to teach you everything on the screen. There's going to be stuff on the screen that we never even talk about, okay? What I'm trying to get you to do is have some mental hooks to help the information stick to. Because it would be real easy on day one, even though we missed a day. I mean, in one day, I could read all this to you real easy. That doesn't mean you could learn it. So when we do anything other than memorize it, we're trying to make the material by teaching it like this to give you some memory hooks and have it to have something to stick to. And we use tissues in a different way than they did in AMP1. In AMP1, it was mostly you just memorize it for this little module or something for this chapter. Now we're showing you that tissues have a certain structure, and those structures have a function. So one of the big pictures of this chapter, endocrine, cube-shaped cells love to secrete, right? Cuboidal epithelium loves to secrete. It's a perfect shaped cell for making a product and then dumping its product. Sometimes it dumps its product in the blood. Sometimes it puts it in a duct. Sometimes, like we haven't talked yet, but in an ovary, those cube-shaped cells are protecting the oocyte, and later the cube cells are going to explode and let the oocyte leave and go get fertilized. So cuboidal cells are really cool. I know they look so simple, but they're really neat. Okay. All right. Next, zoom up from here. Oops. Let's get it there first. Right there. So now you see it a little better. Don't see a lot more still, but you see it better. Good enough that this time, I think most of us, what would I call that thing? Seminiferous tubule. That little structure, that thing is one of those tubes. Okay, seminiferous tubule. What is this right here? Seminiferous tubule. Okay? Remember, it's the entire organ or gland that is what? Yeah, the testes. Okay? But these little structures, hey, what is this right here? Seminiferous tubule. Okay? Now, that average testes, which isn't even a word, okay? But the average single one, a testis, has about 900 of those tubes. That's what they're made from, about 900 of those tubes. And a whole bunch of little cells outside of the tubes. Now, keep in mind, just like we did the ovary, this is an immature testis. It's immature. So this one is not making sperm yet. So these little clusters, if this was an adult human testes, these would be a lot bigger. They might not be that small, okay? Might have a different shape. And that's how the testes change size. They're smaller in babies than they are in adults typically because there's some growth. But we can still learn these things. So then we need to know this. What is the name for that group of cells? Those cells have a name. They are called interstitial cells. Hopefully your A&P1 teacher used the term interstitial space. Maybe they didn't. Anyway, spaces in the body outside of other things can be called interstitial spaces. Where your lymphatic fluid is in the interstitial space. In the testes, anything outside of the tube that's separate from the tube is the interstitial space, and the cells in there, they call the interstitial cells. So it's all those little blue ones and more. Watch this. I could come over here and say, ah, there's some. There's some. There's some. There's some. Just those little clusters away from. Those little clusters away. And here's the neat thing. Those cells make, take a wild guess. This is the endocrine system. What do our cells that we're concerned with produce? Hormones, and the male hormone is? Testosterone. So those little interstitial cells, they happen to be, take a wild guess what tissue type they are. Most glands, cuboidal epithelium, and these are no different. I know you can't tell. That's why I've zoomed the picture up, and I'm going to show you one more picture. Okay, so for this, at this point, it looks like a whole lot more than it is up there. Let me come back and change this because I really want to spell it for you better. S-E-M-I-N-I-F-E-R. That is a seminiferous tubule. Okay. All right, there's your second picture. The way that we're doing it today is I'm going to add a little bit of knowledge to the third picture. Once you know that, I could come back to this picture and ask you. So I want to make sure you see it on the other picture just because of the way that I marked it up here. And then we might come back to this, give you a chance to get that down. I think everybody can see right here. First off, any tube that has a hollow part, do you guys remember from A&P1? What do you call the hollow part of any tube? Very good. Call it a lumen. Okay? And so this whole thing here, even though we don't see it all, what would that be? Yep. That is our seminiferous tubule right there. So we're zoomed up on one. I do want you guys to know, if this were mature, you could see sperm in here. This one's not mature. It's not making sperm yet. That's why you don't see it. When we get to reproductive, I have a picture of one that has the sperm cells that you'll see. Okay. By the way, if you look over here, see how these little things are getting sharp and pointy? They're changing. These cells are changing, and they're getting to the point where they're about to grow a tail, and they're working to become sperm, which is really pretty cool. But here's the neat thing. I think you guys can tell. What's the shape of those nuclei? Round, so those are cuboidal. I'm not going to ask you that on this one because those are part of the tube. What we might ask you is to name those cells. So these cells here, check out their name. They are called spermatocytes. Remember, on the female, we had oocytes. On the male, we have spermatocytes, these cells. Now, the truth is, some of the cells in here are not spermatocytes, but for our purposes, we don't need to know that. So if I point anywhere in here, in this tube, anywhere in there, and say, name the cell, it's spermatocyte. If I point to the lumen and say, name a cell that could be here, what would it be? Sperm. Notice, these are not sperm. These are spermatocytes. They go through a process. We love to talk about it in biology. We don't do so much with it these days in A&P. We go real fast. We don't do it in the lab during lecture. But those cells divide 2 times. And when they divide in their 2 times, they're dividing, they get really small. And this is what's crazy. The smallest cells in the human body are sperm cells. And the largest cell in the human body is the egg, the oocyte. So the sperm are the smallest, and the oocyte is the largest, which is cool. In fact, the oocyte's so big that it's the only cell in our body that if there were just one cell, like on the table there, you might actually be able to see it. It would look like a little piece of dust or something, but you could see it. Sperm cells are 80,000 times smaller. There's no way to see them. Don't worry. You're not going to be asked how much smaller. They're just a lot smaller. Who wants to tell me? Name those cells. Yep, I heard it. Get that out of the way. INTERSTITIAL. Interstitial cells. And what do they produce? Very go. Remember, spelling's important in A&P2 for full credit. So make sure you can spell testosterone come test day. What is this organ? Nice, testes. See, we don't want to forget the basics. I could show you this picture and the question could just say, name this gland. Testes. Could say, name a hormone produced here. Testosterone. Or it could get much more specific. Name this structure. Seminiferous tubule. Name this cell. Spermatocyte. Name this, watch this. If I ever want you to name the lumen, here's the word I'll use. I feel like it's only fair to say name this space because the lumen's it's not necessarily a structure, it's a hollow thing. So I want to clue you into that. I don't want to get caught up on you having to guess. So I would say name that space.
What lumen is like close to
So let's do the lumen. Let's go back one. So let's get this picture and then we'll go back and I'll show it to you on that. It's better because you'll see the whole thing. Okay?
the space close to the interstitial cells.
Right
Or
here.
that-
No, this right here.
Only that.
So in the center of the tubule. So this space, no name. This isn't the lumen. Only in here. But when I get to the other one, I'll point out a bunch of them. Okay. So y'all go ahead and get this picture. All marked up. And then let's go back and let's think about what we added. We added spermatocytes and a lumen, okay? And let's see that on the last picture. Because our first time through, I marked it up so much that I didn't get to that. But the truth is, you could get lumen on here and you could get spermatocytes on here. So. There it is. There it is. This one's kind of funny looking. There it is. All of those things in blue. The lumen. Okay. And remember, I like to ask that like this. Name that space. Most of you won't get that question. You know, it's like rarely shows up in the pools. But somewhere on this test, there's a question that has lumen. Okay. It just doesn't show up a lot. Why does this seminiferous tubule look like it has two lumens? This tube's easy, right? This tube was coming straight at you. The hollow part's in the center. Here's what happened here. This tube came out and turned, and then turned again, and then went down. And so it came out, and it kind of had a lumen there, and it turned, and it kind of had a lumen there. This isn't the best example, but it's a great example of this. The tubes in the testes are not straight tubes. Sometimes you cut them where they are straight, but they're curly, and they're coiling up. So when you look at the testes, you see a lot of different shit. And look at this one. You're like, it's got no lumen. You know what? The tube was going this way, and when they cut it that way, it made it look like there was no lumen. But it's got a lumen too. They all have to have a lumen. It's just where they cut. All right. What are these cells? Very good. spermatocytes. I hate to do that, but I need you to see the word up there. So let me write it over here too. Ooh, look, that's part of a seminiferous tubule right there. Which cells are these? Good, interstitial. And see, we're not doing everything. We're not worried about what that is. We can't tell. Who cares? It's not for us right now, okay? That's for histologists to do and figure out. Okay, go ahead and get this picture because I know you may get spermatocytes or the lumen on this picture as well as that zoomed up picture. It's halftime. Let's take a break. Okay. We did a lot. Here's the good news. We only have 2 slides to do after the break. We did 4. We did pituitary, pancreas, ovaries, and testes. So we have a thyroid and an adrenal gland left to do. And then it just becomes learning the information about the various glands and hormones from this sheet. And I'll give you some tips on that too. So chase away what hormone? Melatonin. And let's take our break.